Hey, Christina,
Hey, Susan.
let's keep talking about confidence intervals.
Okay. Yeah, that sounds good.
Um,
Um,
Are we going to talk about confidence intervals for means this time? Is that what we're doing?
yes. Yes, for
Okay.
means. Yeah, so the first part here, in 3.2, we're not actually finding a confidence interval yet. We're going to use that T distribution, that new distribution that you read about in the beginning part of your notes. We're going to use that T distribution to find critical values.
Okay.
So just a reminder, that margin of error when we're working with means is that T critical value times the sample standard deviation divided by the square root of n. So what we're working on in this little section here is just finding that critical value.
All right.
Sound good?
Sounds great. Let's do
All
it.
right. So a reminder about when to use the T distribution. The requirements there are that we have an unknown sigma, population standard deviation.
Which is almost always the case. We don't
Right,
we don't know the population standard deviation most of the
right,
time.
right, which is why we're using the T distribution.
Yes.
Yeah, and then either the population is normally distributed or my sample size is greater than 30.
Sort of like the same requirements we had for the central limit theorem.
Yeah, yeah, same requirements we had for the central limit theorem. Okay. So I'm not going to read through these properties of the student T distribution. You can look through that, but I will point out the exact shape of the student T distribution depends on the degrees of freedom.
Yes.
Okay. And, so as the degrees of freedom increases, the graph looks more and more like a standard normal distribution.
Oh, yeah. Yeah. So when your sample size gets really large, your
Mhm.
T distribution is really looking a whole lot like a Z
Yes, yeah.
distribution.
Yeah, and for our one variable data for means, our degrees of freedom, we're going to have n minus one. So our sample size minus one.
Right.
Yeah. Okay. So let's practice finding a couple of these. Okay. So first, are the requirements met to use the T distribution? And if so, find the critical value and sketch a graph of the distribution.
Okay.
Okay. So the first one here, I want a 95% confidence level. So
Hmm.
that's confidence level, 95%.
Okay.
I'll write as 0.95.
Okay.
Sigma is unknown, and the
Okay.
population appears to be normally distributed.
Which is good because you either need that or a sample size greater than 30. And when I was looking at the sample size of 23, I was like, man, I hope that thing's normally distributed.
Yep.
Okay, so the
So,
population's normally
oh,
distributed. We can use it.
yes.
Okay.
Sorry, I don't know.
What 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 happened here,
I'm
Christina?
sorry, I hit something and I don't know where it went. Okay. I don't know what I touched. I'm sorry.
There we are.
Okay, we're back. Okay,
Yay, we're back.
so it meets the requirements.
Uh-huh.
Okay. And then, we've got this graph shown here in the answer key, but let me pull up StatCrunch too, and we'll show them how to do this in StatCrunch. Yeah.
Okay. Yeah, that sounds
Okay.
great.
All right. So just a reminder, when I'm looking for critical values, and this is the same as it was for proportions, that 95%, that confidence level is the central area on the distribution.
Okay, can we mark that bell curve that we've got over there? Can we mark that with the 0.95?
Yeah. So this area here is 0.95.
And then circle it down there where we put it in yeah, there it is, 0.95. Okay.
Right. Yeah. So in StatCrunch, I'm going to go to um, stat calculators, and then T is down toward the bottom. And it
Okay.
doesn't say students T here, it just says capital T.
Yeah.
That one. Oops.
Now what?
Nothing. I'm nothing.
How's it going over there?
It's going great.
Okay.
Going great. So,
Sample size was 23, right?
Yeah, sample
So
size was
degrees of freedom is
23.
22.
And
Subtract 1.
I need to delete that. And that makes the
Oh, you are so
freedom.
cool. You know, I didn't even know this would do this until Christina showed me. You could just handwrite it and uh-oh.
Ah, I'm fine. It's fine.
I'm
Everything's
fine.
fine.
It's
Okay.
fine.
Everything's fine. So I put in degrees of freedom of 22.
Okay, and
But
now we're gonna
then
hit between.
we're gonna hit between. Thank you.
And then it was a 95% confidence level. So we're gonna go over there where the area is, and we're gonna tell it that the area is 95.95.
Yeah.
What are we doing here?
I don't know. This little thing won't go away. I can't. Oh, I can move it. Okay, I moved it. Okay.
Okay. That's it. So we've got degrees of freedom 22. Area in the center is 0.95. Now let's get those two
There.
values. Okay, so our critical value, we're just going to report the positive one because we do plus and minus to get our interval, and that deals with the negative one. So we're just going to report 2.0739.
Yep. And
our
that
critical
is
value.
what we have over here.
Oh, is it? Because I can't see it.
Sure is. Yeah, it is. See, it's there.
There.
Okay. Golly, we're having some
God.
difficulties.
Okay. So we have
Yeah.
2.0739. So can we, yep, and you've got it written there. Can we circle it?
Yeah, I have it written here. I'm going to write it a little bit bigger though, okay?
Wait, you actually got it typed in right up above the picture.
Oh, yeah. Yeah, I've got it up there. Okay.
How's it going over there, Christina?
It's great. It's great. Pen's not working anymore. We might
Yeah,
have
you know
to.
what? I'm just going to pause the recording and then we'll
Okay.
continue in a minute.
Mhm.
Oh, and we're back.
Yeah.
All right. And
Okay.
now Christina has circled the critical value of 2.0739.
Yeah. Got that pen working again.
Excellent.
I don't know what happened. Okay. All right. Let's do one more of these. And
Oh, yeah. Because I know
yeah.
they can't wait to see us do one more of these. Oh.
Okay. Yes. All right. So B actually says a 99% confidence interval. N
Okay.
equals 6.
Wait, and right there, that's giving me, N either has to be 30 or we have to have a population that's normally distributed. So N small. Well, what else we got?
We have that the population appears to be very skewed,
Yeah, I don't think we can do it. I don't
right?
think we can.
So that does not meet the requirements.
Okay.
Can't do it. All right, so let's skip to the next one here. I have a 99% confidence interval.
Okay.
N equals 25.
Which
So
isn't big enough, but let's keep
equals
going.
25, but my population appears to be normally distributed,
Yes,
so
we can do
that's
it.
okay. Right.
Okay.
So what are my degrees of freedom?
24, because it's 25 minus 1
And then the confidence level
is 0.99, is
Mhm.
99%, which would be 0.99 area. And you can see on the picture that we've got there that you have put in 0.99 as the central area in a between problem, and we have degrees of freedom of 24.
Yeah. And so that central area there is 0.99. And so I should get critical value of 2.7969.
Okay.
Okay.
And yes, and I see it. I mean, I can see there where you've marked that bar. It's between 2 and 3 and closer to 3. So yeah, I see that.
Yep. Good. Yeah, so that cutoff value right there, that's what we're looking for. That's our
Okay.
critical value. Good. All right. Let's make another video where we actually make confidence intervals. Yeah.
Let's do that.
All right, cool.
Great. See you later.
Bye.